This is the post-lab discussion for the circular motion lab that you should have completed in class. At this point, you should have already graphed the data, linearized the graph, and you should have an equation written from the linearized graph with the units as simplified as possible. So that's where you should be before you start this video. Okay, as we look at this, I'm going to go back through what you should have done, and we'll look at what your equation should have come out to be, and then what each of the things in the equation means. So the first graph that you should have got should have looked something like this. So you should have had a top opening parabola shape to your graph, and whenever you see that, that tells you that you need to square the x variable in order to linearize it. So we go ahead and do that here. Just as a review, it's a new semester and I know you kind of forget things over break. The whole reason that we linearize is to see if our assumption about the initial relationship is actually true. It's possible that we could assume that the first shape is a top opening parabola and it may not actually have that mathematical relationship to it. So if we graph the f versus v squared in this case, if we were incorrect about our assumption, then we would get a shape that's not linear and we would have to deal with it from there. So in this case, we are correct. And you should have, when you square the x data, come up with a graph that is then linear when you graph force versus velocity squared. Notice that the unit on the x-axis should now be meters per second quantity squared. So I have a sample equation here. Yours might look slightly different. I just kind of made up numbers, so don't panic if your numbers are different than mine. But I have the net force, which is what we should have been graphing on our, when we recorded the data, it should have been the net force, not just a component force. So we've got the net force equal to 2.5, that's the number I made up, kilograms per meter. If you don't have that unit, I'm going to show you where I got that from. That's a simplification of a Newton divided by a meter per second quantity squared. That simplifies into a kilogram per meter. So I have that times my x variable, which is v squared. I often see students forget to put the x variable, especially when they have a bulky unit on their slope. So don't forget the v squared here. And then I have eliminated my y-intercept. My y-intercept would have the unit of a Newton. Since it's when the velocity squared is 0, that would be the net force. So I've eliminated that based on the data that I pretended that I had. Okay, and you should be able to do that. There shouldn't be anyone that has to keep a y-intercept in this lab. Okay, so let's first look at what the slope means. So we always look at the units to determine the meaning of the slope. So in this case, our unit started out being a Newton divided by a meter per second quantity squared. So in order to simplify that, I'm going to have to break down a Newton into its component units. You should remember that a Newton equals a kilogram meter per second squared. So that's what I have there. And then I went ahead and expanded my meter per second quantity squared into a meter squared over a second squared. So now I have something that looks a little easier to simplify. I see some things that I'm going to be able to cancel out. Since I'm dividing these two, I'm going to go ahead and, oh, there's my component Newton. Nice animation, very pretty. So I'm going to take my Newton, which is the kilogram meter per second squared, and I'm going to multiply it times the reciprocal of the meter squared over second squared. So when I do that, I'm going to be able to eliminate all of the second squared, and I'll be able to cancel out one of the meters. So when I do that, now I have a much prettier unit, a kilogram divided by a meter. So your job in this lab, or in any lab, is always to find out what does the slope actually physically mean. So now that I have simplified units, I can think, well, a kilogram per meter, I don't think that's a unit of anything all by itself. So what I'm going to think of then is that a kilogram is a unit of mass. And since this is the slope, and on the linearized graph your slope was constant, you need to think of what was a constant mass that you used in this lab. That should have been whatever the mass of your pendulum bob was. So the other part is the meter. So again, this is a constant thing. So what was constant in your lab that was measured in meters? That should be the radius. So when I look at those two together, I should be able to determine that the slope is the mass over the radius, and that's due to its units of a kilogram per meter. So now that you know that, you should be able to take a minute and find your percent error, and I want you to do this and bring this into class. So you're going to take the accepted, which is what you measured to be your mass and your radius. So take the mass that you used divided by the radius that you measured, and that'll be your accepted value. So take that minus your experimental, that's the value of your slope, divided by your accepted again, your own mass versus radius. So do that, absolute value times 100, and that will be your percent error for this lab. So then you want to look at what your y-intercept mean. I already showed you that I eliminated it by the 10% rule, but here's the logical reason that you shouldn't have a y-intercept. If you don't have any velocity, you shouldn't have a net force on your pendulum. And that's true because we zeroed out the force sensor before you started. So if you actually zeroed your force sensor, you should not have a y-intercept. Okay, so now we take our general equation from the y equals mx plus b. Guys, I do not want to see y equals mx plus b in your lab reports. We just use that to say, hey, that's the general equation for any line. What is the equation for the line that you came up with in your lab? So we substitute in. So the y variable was net force, the slope is mass over radius, and then the x variable is velocity squared. So this is the general equation for your lab. Normally, the way this physics equation is written in textbooks and such, it's written differently where you have mv squared over r. It means the same thing. So you could have this, the one on the left or the one on the right. Either one of those would be correct to put in your lab report as the general equation. And remember, the general equation only belongs in your conclusion. You shouldn't have that in your evaluation of data yet. Okay, and then I have it written out in words for you if you like that for your notes. Okay, so you should always answer when you do a lab report. You should always say, if your purpose was to find the relationship between force and velocity, you should be able to answer in your conclusion, what was that relationship? In this case, you could say that there's a direct relationship between force and velocity squared, and you know that because you have a linear graph. There's a few other ways that you could state that relationship, but I think that's a nice, concise way to do it. Okay, part of your conclusion, you should answer these questions as well. If you were to perform the experiment again, how could you change the slope? I'm not going to answer that for you. I want you to think about that and figure it out and write that in your lab report. You know what your slope actually means now, so what could you do that would give you a bigger slope, and what could you do that would give you a smaller slope? List both of those, what you would do to produce that if you were to do the lab all over again. Okay, yep, include the effect that you that has on the slope. And the second question, how could you change the y-intercept? Again, I'm going to leave that up to you to figure out. Identification of error. Remember, we don't do error in a lab to make you feel bad about how you did your lab. The idea is to recognize the limitations that we have. There could be some human error in this lab. Never just say there was human error without explaining what that means. It was not the error of humans everywhere that caused you to have error in your lab. Be specific what would cause you to have error. So there could be some human error. There's also some equipment limitations, and you can list some of those there as well. So that is the end of the post-lab, and you should be able to start working on your lab report. It's, as always, due a week from Friday from when we do the lab.